Form and complete a full two-mean hypothesis test with population standard deviation unknown. We're going to use the critical value approach. So first we have ourselves a really big problem. Now, when you look at a problem this big and you start to get a little anxious because this is math, there shouldn't be words, don't fret. Get yourself a piece of paper and write down all of the important information as you read through. It'll help keep your thoughts organized and make things easier later. All right, let's jump in. A cardiologist concerned about the heart rate of a patient asked the patient to undertake a new cardiovascular exercise program. The cardiologist measured the patient's heart rate during 15 random workouts completed by the patient during the new exercise program. The mean heart rate for these workouts was 177 beats per minute with a standard deviation of 2.4. The cardiologist compared this with a sample of 15 random workouts completed by the patient during the patient's previous exercise routine, which had a mean heart rate of 180 beats per minute with a standard deviation of 2.5. Assume that the heart rates for both types of exercise routines are normally distributed. Let the patient's previous exercise routine be the first sample, and the patient's new cardiovascular exercise program be the second sample. At the 0.10 level of significance, is there sufficient evidence that the patient now has a different average heart rate during the new exercise program? Work through the test procedure and interpret the results of the hypothesis test. Before we do that, let's review the steps of the hypothesis test. So first we're going to identify the null and alternative hypothesis. We're going to decide on the significance level. We will then compute the test statistic. We will use that test statistic to find the critical value, and then we'll be able to interpret the results of the hypothesis test. All right, let's jump in. First, we're going to identify the null and alternative hypothesis. So recall, the null hypothesis always shows the equality, and the alternative hypothesis shows the inequality. Therefore, we know our null hypothesis is going to be mu1 equals mu2, where mu1 is the mean of the old exercise program, and mean 2, the second sample, is the mean of the new cardiovascular exercise program. And because we want to see if there is a difference in heart rate, we're going to use the not equal to. Because we don't necessarily care if it's higher or lower, we just want to know if it is different. So our alternative hypothesis will be mu1 is not equal to mu2. Let's move on to the significance level. It tells us that the significance level is 0.10, and therefore that is our value of alpha. We're going to use that to find our critical value. Now to compute the test statistic. It is always important for you to recognize what formula you're going to need for this. Now, because the standard deviation, the population standard deviation is unknown, we're going to use our t distribution, so the t test statistic, and we have the formula you can see here. Notice all of the little sub numbers, the ones with sub 1s, those are going to be our first sample, right? The previous exercise routine, and then all of them with the sub 2 after it are the new cardiovascular information. So make sure you keep those separate, it's very important. We go back to our problem when we find our given values. Again, if you wrote all of this down as you read through the problem, it makes it a whole lot easier later. I do recommend you write out the formula with symbols, you write down the given values, and that makes it a lot easier to substitute the values into the formula. You want to make sure that, because if you have one number wrong, it throws off your whole answer. So everything that deals with the old exercise program, we plug in accordingly, as well as the new cardiovascular program. If you're plugging this into your calculator, please make sure you use parentheses. You've got to make sure we follow the order of operations. And when we do that, we end up with a test statistic of 3.35. Excellent. Now to find the critical value. Because we're using the t distribution, we're going to need to find the degrees of freedom. So first, to identify the degree of freedom, we need to find the critical value. The estimate of the standard deviation is non-pooled because the standard deviations are unequal. That's the sample standard deviations that we were given. Remember, one was 2.4, one was 2.5. Since the estimate of the standard deviation is non-pooled, the conservative approach to calculate the degrees of freedom is to use the smaller of n sub 1 minus 1 and n sub 2 minus 1. The two sample sizes of each item, the smaller. Well, both of our sample sizes are 15, so therefore our degree of freedom will be 15 minus 1, or 14. So using our t distribution table, we're going to go to the line of the degree of freedom is 14. We know that the level of significance is 0.10, and this is the area in two tails because we have a non-equal to alternative hypothesis. So if you go with that area in two tails, we end up with a critical value of 1.761. And again, because it's two tails, we're going to have the negative for the left tail, negative 1.761, and then a positive on the right. Now that we have our critical values and our test statistic, we are ready to interpret the results of the hypothesis test. Our test statistic of 3.35 is greater than the critical value. If you would draw the normal distribution curve and put the critical value in, we would see that 3.35 falls to the right because it is greater. Therefore, it falls in the rejection region, and the conclusion is to reject the null hypothesis. Therefore, the interpretation at the 10% significance level, the data provides strong evidence to show the patient has a different average heart rate during the new cardiovascular exercise routine compared to their previous exercise routine.